Here we have an application that involves a logarithmic equation or function. It's students in a computer science class took a final exam, and they took equivalent forms of that exam at monthly intervals after that. Okay, the average score, S of t, as a percent after t months was found to be given by this big function here, and t is going to be greater than or equal to 0. So first question, what was the average score when the students initially took the test? So that would have to be times 0. That's the initial. What we're going to do is just plug that in here to our function, and I could do this on the calculator. I could just take 78 minus 15 times, and this is plain log, so it's the common log here, of 0 plus 1. Yes, I could have done that in my head, but I'm just putting it all in there. I don't have to really do any of it, and it tells me the average score initially was 78. And they said, okay, what about the average score after 24 months? Well, t is the number of months that have elapsed, so we want S of 24. We'd put a 24 in, work it out, and you should get 57 on that one. Now, an interesting question, though, is after what time was the average score only 50%? So how long did it take for them to only remember 50% of what they studied in this course? Well, what we're doing then is we're saying the answer here, S of t is 50, right, equals this logarithmic equation or function. So I don't have the tools really to solve this algebraically. I'm going to solve it graphically. And all I'm going to do is put one side of my equation in as y1 and the other side as y2. I do want to keep in mind the context here. T stands for time in months, so it makes sense to me to do 0 to at least 120. Let's go 10 years out and see how well they did. And I used a scale of 12 here because then 12 months would be a year, so every tick mark would represent a year. Now on the y's, a lot of times I start at 0, but for this one, because the logarithmic function here it's a very slow decline, that's too much space and I don't see it very clearly. So I said, well, 30% of the test to 80% of the test. That would give me a nice window around the 50. So I have it graphed on screen, but I also put it in my calculator here, and I've got it graphed, I think. Oh, I forgot to put it in the second one, didn't I? So the second side would be 50. And it doesn't matter which one's x and y1 and which one's y2. So I've got my graph here. And if I want to know what that intersection point is, I go to the calculate menu and I choose number 5, intersect, and we answer those 3 questions. Is this our first curve? Yes. Okay. Is this our second curve? Yes. And then what do I think is the point of intersection? Well, right about there where it looks completely flat, and it tells me about 72.56, same answer I got there, good news. So that would be about 73 months or just over 6 years. So these guys were good.